morning or good afternoon everyone. We are group 4 from block A and today we will be talking about the ellipse. So alright, so the figure you see here in the whiteboard is actually an ellipse, but well, it's not that perfect, but we guarantee that it's actually okay for learning or demonstrating purposes. So let's consider 2 points here, that's F1 and F2 with the coordinates of -3, 0 and +3, 0 respectively. Okay, the question, we put 1 point A, that is 4, that's around 4, and 2.4, let's say around here, and another point which is around here. This is, we have your point A and your point B. Now these 2 points are points on the ellipse with the respective coordinates of 4, 2.4, and 0, 4. Okay, the question, what is the sum of the distances between AF1, which is this one, and AF2, and another one which is from here, B to F1 and B to F2. Okay, now from earlier calculations, we were able to find out that if you add AF1 plus AF2, it will give you around 10. Why? The distance of AF1 from calculation using the distance formula is 7.4, while AF2 using the distance formula we will get 2.6. If you add them both, you get a 10. Now, in the next case of B, BF1 plus BF2 is equals to 10. Why? If the distance from here to here using distance formula with earlier calculations is 5, and then here B to BF2 are 5, is equals to 10 units. Now, if you notice that the distances of this and this, of AF1 and your AF2 and your BF1 and your BF2, they produce a constant. Now, there are other points in this ellipse that when you add, there are other points in point B, such that when you add them both, which is BF1, point F1, and point F2, equals to 10. And the collection of such points is what we call an ellipse. So with that, we have BF1 and BF2 plus BF2 is equal to 2A. Now from this equation, with careful derivation, we could get the standard equation of your ellipse, which is x squared over a squared plus y squared over b squared is equal to 1. Now you might ask, how did this simple equation get to this? Now we will explain it to you right now. So why that? Okay, now if you remember, your foci are -C0 and +C0. Now what we just did is just to substitute these values onto your distance formula, and then of course it's only y squared since it's 0, and then we have x plus c squared, then it's plus because it's negative first, it's negative, and then minus because it's positive right there. So what we do next, we square both sides, and then after we square both sides, we simplify what's inside of this. So we will get x squared plus 2cx plus c squared plus y squared, you retain your y squared, is equals to, now this becomes squared. Now this is a binomial. Now we will do FOIL method, and that is done behind the scenes. So what will happen now is we get 4a squared minus 4a, then we just simply copy this, that is x minus c squared plus y squared, and then we get the square of this, which is x squared minus 2cx plus c squared, plus y squared. Now, what we do next is transfer this part of your trinomial to the other side. So what happens now is x squared plus 2cx plus c squared plus y squared. Now all signs there will change. That's minus x squared plus 2cx plus c squared. Oh no, that's minus, by the way. I'm sorry for the mistake. It's minus. Then minus y squared is equal to 4a squared minus 4a. Then retaining your c squared plus y squared plus x squared. That's still part of your radical. Okay, now the values cancel. We have here, that's cancelled. It's cancelled because they're negatives. Then we have 2cx, then 2cx becomes 4cx is equal to 4a squared minus 4a. Then we still copy that, x minus c squared plus y squared. So we have that, and then we take out 4 from both sides. It's 4cx is equal to 4. Then we have a squared minus a. Then we still copy that. That's x minus c squared plus y squared. And then we divide both sides by 4. Now what will happen is that we have only cx is equal to a squared minus a. That's x minus c squared plus y squared. Now this term, these two terms here, the cx here and this will exchange spaces. So this moves here and this moves here. So it becomes positive a x minus c squared plus y squared is equal to a squared minus cx. Now, I'm sorry for the smudge. That's c squared plus y squared. Now, from that, we will continue to get to the standard equation. So we have this equation, and what we will do is square both sides. So we have square. So then again, like earlier, aside from taking off the radical, we'll also simplify what's inside. So that's a squared bracket. That's x squared minus 2cx plus c squared plus y squared. And then, as this is a binomial, we do the FOIL method, which is done backstage already. That's a to the power 4 minus 2a squared cx plus c squared x squared. Okay, now we will factor because both sides are factorable, so we factor them. So here, if we notice that c squared c for that matter of fact can be extracted away, so we substitute b squared on both sides. So we substitute b squared x squared plus a squared y squared is equal to a squared b squared. Now we divide both sides. And then of course this cancels. Then on each side we have b squared x squared a squared b squared plus a squared y squared over a squared b squared. And of course there are cancellations. So we have our final equation, which is x squared over a squared plus y squared over b squared equals to 1, with an important note that a is greater than b. Now since we implied this situation, now if you remember, your square root cannot be negative, so therefore we can imply that your a must be greater than b and therefore must be greater than c. So with that, we can say that your here a is greater than your b, and this inequality will be important as we discuss your properties.
So here we have an ellipse with an origin or center at 0, 0. So each focus is c units away from the center. So as we can see here, focus 1 is c units away from the center. So this is your focus. So we get an equation, an foci with positive or negative c0, or f1 is negative c0, f2 positive c0. And it could be interchanged wherein f1 could be positive c and f2 could be negative c. So vertices are points in the ellipse collinear with the center and the foci. So if y is 0, then your x is positive or negative a. So v1 is negative a0, v2 is positive a0. Same with the foci, it could be interchanged wherein v1 could be positive a and v2 could be negative a. Then the segment v1, v2 is called your major axis, and its length is 2a. And it divides the ellipse into two congruent parts. Next, co-vertices. The segment that runs through the center and is perpendicular to the major axis is your minor axis. It meets the ellipse at the co-vertices. So if x is 0, then your y is positive or negative b. So w1, 0, negative b, w2, 0, positive b, and it could be interchanged. Then w1 and w2, the distance is 2b. Then it divides the ellipse into two congruent parts. However, some ellipses have their foci aligned vertically and have centers not at the origin. If the y part has bigger denominator, the ellipse is vertical. For the horizontal ellipse, the foci is h plus minus c, k. Then the vertices h plus minus a, then k. Co-vertices are h, then k plus minus b. For the vertical ellipses, their foci are h, k plus or minus c, vertices h, k plus or minus a, then co-vertices h plus or minus b, then k. Their eccentricity is c over a, then their lateral recta is 2b squared over a. Now let's go to the examples.
So our example is 2x squared plus 3y squared minus 6x plus 6y equals to 57 over 2. So the first thing we need to do is to find the standard form of the equation. So we need to remove the denominator by multiplying both sides by 2. After multiplying both sides by 2, we need to group the terms. So this is the equation after grouping both terms x and y. So after grouping terms, we must factor out all the common factors of the terms. So the common factor of the terms x is 4 and the common factors for y is 6. So we got this equation. So the next thing we need to do is to complete the square. So 3 over 2 squared is equal to 9 over 4 and 2 over 2 squared is equal to 1. So we must add both sides by the two constant terms. So 9 over 4 and 1 is added. Since there is 4 and 6 factored out, we must put 4 and 6 to the other side. So we square the terms and we get x minus 3 over 2 squared and y plus 1 squared. since we multiplied this to that, we got 9 and 6. So 57 plus 9 plus 6 is equal to 72. So the next step is to divide both sides by 72 since we need the right side to be equal to 1. So divide both sides by 72, bring down 4, and bring down 6. We get 18 and 12 and 1 on the right side.
So the given focus is positive, negative, 3 over 2 and 0. And we got the center, which is 0, 0. So we got the C from the focus, which is 3 over 2. We then use the formula to get the eccentricity, which is E equals C over A. We then substitute E with 3 over 4 equals 3 over 2 over A. And then we transfer A to the other side, which would make it 3A over 4 is equal to 3 over 2. And then we cross multiply 4 to 3 and 3 to 2. We will then get 6A is equal to 12. To get the A, we should divide 6 here and on the other side. So then we will get A is equal to 2. So we then square A to get 4 so that it would fit in the first term. And then to get the second term, we would derive the formula for C, which would then make it B squared is equal to A squared minus C squared. And then when we substitute it, it would become B squared is equal to 2 squared minus 3 over 2 squared. When we square these values, it would become 4 minus 9 over 4. So 4 minus 9 over 4 would become 7 over 4, which would give us the second term.